All right, welcome back. Last lesson of the week, and it's dealing with a little bit more percent yield. This time we're going to kind of work it backwards. So the example problem's on the board. In the combustion reaction of dicarbon dihydrogen, which is the exact same one that we've been using all week, you're able to achieve a 94% yield of water. If you started with 30 grams of dicarbon dihydrogen and an excess of oxygen, what mass of water was produced? Mrs. O'Loughlin, if you would pause it right now so the students can write this one down in their notes. When everybody's ready, we'll get started again. So let's remember that the percent yield equation was actual yield over theoretical yield times 100. So in this problem, what we have to realize here is what mass of water was produced. This is the amount produced in the laboratory. So what we are finding here is the actual yield. So this is our unknown. This is our variable in the problem. All right, so in order to solve for the actual yield, we have to know the percent yield, which we do know, 94%, and we need to know the theoretical yield. The theoretical yield we don't know. This is something we're going to have to do stoichiometry with to solve for. And here we've got a little bit different situation because it tells me I have 30 grams of the C2H2 and an excess of oxygen. So this time, the C2H2 is our limiting reactant, and the oxygen is the excess. So to remember to calculate the theoretical yield, you always use the limiting reactant, and you do stoichiometry. So let's go ahead and do it. We've got 30 grams of the C2H2. And we're going to do our stoichiometry and figure out how much water that's going to produce. So let's go ahead and convert that into moles. So we've got C2 is 24, that's 26 grams is 1 mole. Grams are going to cancel out. And we need the, oh shoot, I forgot to put that up there. We're going to need the chemical equation. Remember, it's 2C2H2 plus 5O2 is going to yield 2H2O and 4CO2. And that's going to give us our molar ratio of 2 to 2. Hey, it's a 1-to-1 molar ratio. Fantastic. So let's see here. We've got 2 moles of C2H2, and we've got 2 moles of water. We go ahead and find out the mass of water, knowing that 1 mole of water is 18 grams of water. Double checking here. Let's see. Moles of H2O on top and bottom cancel out. Moles of C2H2 on top and bottom cancel out. And grams already canceled. And let's go ahead and do the math. Okay, so multiplying across, dividing by the stuff on bottom, we end up with 20.8 grams of H2O. And that is our actual yield. So we're going to go ahead and take that and plug it into the equation above. Oh, sorry, that's not our actual yield. That's what we're trying to find. That is our theoretical yield that we found through stoichiometry. So since we know now the percent yield, we know the theoretical yield, we can plug in what we know and solve for the unknown. So the percent yield was 94. The actual yield is unknown. Let's just go ahead and put an X in. The theoretical yield was 20.8. And we don't forget the 100%. You can leave off the 100%, the 100 on the other side, if you do the percent yield as a decimal, 0.94. And you're going to see why that is. Let's go ahead and solve for x. So we divide both sides by 100, which is where we get the 0.94. Let's move to the other page here. So we're going to have 0.94 is equal to x over our theoretical yield, which was 20.8. Multiply both sides by 20.8. And throwing that into the calculator, we end up with 22.1 grams of H2O is what we actually measured in the lab being produced. Double check to make sure it makes sense. Let's see here. Well, our theoretical yield, again, was 20.8. That does not make sense. 22.1. Back up. I did that on purpose just so we could emphasize the importance of checking our work to see if it made sense. I know it didn't make sense because how could my actual yield be more than the theoretical yield? Somehow I got extra water in the lab? No way. I actually did the problem wrong. I found out that I divided by 0.94 in my calculator rather than multiplying by 0.94. So when we do the math right and we do 20.8 times 0.94, we actually get 19.6 grams of H2O. That is our actual yield, and that makes sense. Your actual yield should never be more than your theoretical yield. If it is, you violated the law of conservation of mass, and you're in big trouble with the chemistry gods. All right? So, these problems are mirrored on your homework assignment. Go ahead and get started with the people in your group. And just remember that it's a balmy 79 degrees in Orlando today. I'll see you guys on Monday.